Sound, in its simplest form, is a wave, a vibration that travels through a medium, like air or water, to reach our ears. These vibrations are created by objects that move back and forth, causing the surrounding medium to compress and decompress in a rhythmic pattern. Imagine a pebble dropped into a still pond. The impact of the pebble hitting the water creates a disturbance. The impact creates ripples that spread outward from the source. These ripples are similar to sound waves, which also travel outward from their point of origin. Sound works in much the same way, with the vibrations acting as the ripples. When an object vibrates, it sends out waves of pressure that move through the air, water, or any other medium. These vibrations, or sound waves, cause our eardrums to vibrate as well. The eardrum then transmits these vibrations to tiny bones in the middle ear, which amplify the sound. Our brains interpret these vibrations as the sounds we hear, from the whisper of wind to the roar of a jet engine. Each sound is unique depending on the frequency and amplitude of the waves. The frequency of these vibrations determines the pitch of a sound, with higher frequencies producing higher-pitched sounds. For example, a violin string vibrating quickly produces a high note. The amplitude or height of the sound wave determines the volume. Larger amplitudes result in louder sounds, while smaller amplitudes produce softer sounds. Louder sounds have greater amplitude, just as taller waves in the ocean carry more energy. This is why a loudspeaker cone moves more dramatically when playing loud music. Whether it's a gentle melody or a thunderous boom, all sounds share this fundamental characteristic: they rely on a medium to propagate. Without a medium, the vibrations cannot travel. Without a medium, sound simply cannot exist. This is why space, which is a vacuum, is completely silent. This is why understanding the nature of sound is crucial to comprehending the profound silence of space. In the vast emptiness of space, there is no air or water to carry sound waves, leading to an eerie, absolute silence. The vast expanse of space, unlike our planet, is a near-perfect vacuum. This means that it lacks the air and other materials that are essential for sound waves to travel. On Earth, sound waves move through the air, water, and even solid objects, allowing us to hear everything from a whisper to a thunderclap. It's a region largely devoid of matter, the very substance that sound waves need to travel. In space, the particles are so sparse that they can't collide and transfer the energy needed to propagate sound. While there are trace amounts of gas and dust scattered throughout the cosmos, the density of these particles is far too low to transmit sound as we know it. Even in the densest regions of space, the particles are still millions of times less dense than the air we breathe. Picture sound waves as ocean waves crashing on a distant shore. The energy of the waves is carried by the water, allowing them to travel long distances. The water acts as the medium, carrying the energy of the waves. Without water, the waves would have no way to move, and the energy would dissipate. In space, it's as if the ocean has vanished, leaving only an empty abyss. This vast emptiness means that sound waves have no medium to travel through, rendering space completely silent. Without a medium to carry these vibrations, any sound produced in space would have no way to reach our ears. Even if you were to shout at the top of your lungs, the sound would be trapped inside your spacesuit. A supernova, despite its unimaginable power, would explode in absolute silence. The energy released would be immense, but without a medium to carry the sound waves, it would be eerily quiet. The collisions of galaxies, a cosmic ballet of unimaginable scale, would be a soundless spectacle. These massive events, which would be deafening on Earth, occur in complete silence in the vacuum of space. This absence of sound is one of the most profound differences between our terrestrial experience and the reality of outer space. On Earth, sound is an integral part of our environment, from the rustling of leaves to the roar of a waterfall. It's a stark reminder of the unique conditions that govern our planet and make it a haven for life and sound. The presence of a medium-like air is what allows us to experience the rich tapestry of sounds that make up our world. Our sun, a raging inferno of nuclear fusion, is a symphony of activity. While we can't hear the sun directly due to the vacuum of space, we can imagine the cacophony it would produce if sound could travel through the cosmos. Imagine the roar of billions of nuclear explosions occurring every second, the hiss of superheated plasma, and the crackle of powerful magnetic fields. Solar flares, sudden bursts of energy from the sun's surface, would likely sound like colossal lightning strikes, their energy crackling across the solar system. The movement of immense loops of plasma, called prominences, might produce deep resonant hums as they twist and turn under the influence of the sun's magnetic field. And what of the sun's interior? Scientists believe that the sun's core, where nuclear fusion takes place, could generate sounds akin to a continuous, low-frequency rumble, a cosmic bass note underpinning the sun's symphony of activity. The sun's surface is far from static. It's a roiling, boiling mass of plasma, constantly in motion and full of surprises. It's a dynamic and ever-changing environment, marked by phenomena like solar flares and sunspots that hint at the immense energies at play within our star. These features are not just random occurrences, they are driven by the sun's complex magnetic field. Solar flares are sudden, intense bursts of radiation from the sun's surface, often associated with sunspots, which are cooler, darker regions on the sun's photosphere. These flares can release as much energy as billions of atomic bombs detonating simultaneously. Imagine a colossal rubber band, twisted and stretched by the sun's churning magnetic fields. The tension builds up over time, and when it finally snaps, the energy is released in a spectacular flare. When these fields snap and reconnect, they release vast amounts of energy in the form of solar flares. This process, known as magnetic reconnection, is a key driver of solar activity. These flares can disrupt radio communications on Earth and even pose a threat to satellites and astronauts. The charged particles from these flares can interfere with electronic systems and increase radiation exposure in space. Sunspots, on the other hand, are like windows into the sun's interior, where magnetic fields are particularly strong. They are regions where the magnetic field is so intense that it inhibits the flow of hot plasma from the sun's interior. They appear darker because they are cooler than the surrounding plasma, but they are still incredibly hot, with temperatures exceeding 7,000 degrees Fahrenheit. Despite their cooler appearance, sunspots are a sign of the sun's magnetic activity. These solar fireworks are a testament to the sun's power and complexity, reminding us that even our seemingly stable star is a celestial cauldron of activity. The sun's surface is a dynamic dance of energy, constantly changing and evolving, a true marvel of our solar system. Section 5. A Star's Hidden Language, Decoding the Sun's Magnetic Mysteries. The sun's magnetic field is a driving force behind much of its activity, from solar flares to the solar wind, a stream of charged particles constantly flowing from the sun. Understanding this magnetic field is key to unraveling the mysteries of our star. Scientists use a variety of instruments, both on Earth and in space, to study the sun's magnetic field. These instruments measure the strength and direction of the field, allowing scientists to create detailed maps of its structure. By studying these maps, scientists can track the movement of magnetic fields on the sun's surface and predict when and where solar flares and other eruptions might occur. This information is crucial for protecting our technology and astronauts from the potentially harmful effects of space weather. Section 6. Beyond the visible, expanding our sensory perceptions of the cosmos. While we can't hear the sun's symphony directly, we can still listen to it in other ways. Scientists convert data from instruments that observe the sun's vibrations into sound waves we can hear. This process, known as data sonification, allows us to experience the sun's activity in a whole new way. Through sonification, we can hear the rhythmic pulses of the sun's interior, the crackling energy of solar flares, and the eerie hum of the solar wind. It's a reminder that there's more to the universe than meets the eye, or in this case, the ear. By expanding our sensory perceptions beyond the visible, we gain a deeper appreciation for the wonders of the cosmos and the intricate processes that govern our star. Section 7. A Universe of Sound and Silence, Pondering the Music of the Spheres. The silence of space, while profound, doesn't mean the universe is devoid of sound altogether. In fact, some regions of space are filled with gas and dust dense enough to transmit sound waves, though not in a way our ears could detect. For example, the gas clouds surrounding black holes can be so dense that sound waves can travel through them. These sound waves, however, are at frequencies far too low for us to hear. Scientists have detected these infrasound waves using specialized instruments and even converted them into audible sounds, revealing a hidden symphony of the cosmos. The contrast between the silence of the vacuum and the potential for sound in other parts of the universe highlights the diversity and wonder of the cosmos, reminding us that there's always more to discover. Section 8. A Cosmic Shoutout. Thanks to Ali and a call for continued exploration. A big thank you to Ali for suggesting this fascinating topic. Exploring the nature of sound and the silence of space reminds us of the incredible diversity of the universe and the importance of scientific inquiry. I encourage you to continue exploring the wonders of the cosmos. Read books, watch documentaries, and never stop asking questions about the universe around us. Who knows what other secrets the universe holds waiting to be discovered? And once again, thank you, Ali, for your wonderful suggestion.